Hello, my name is Tim Case. I'm the MCP project manager for networking, and I'll be talking about the changes we've made for the MCP 19 release. We have a number of topics to discuss today. The first change we've made has to do with increasing transaction processing scalability. I'll also be talking about our implementation to RFC 5961, changes we've made to update our IP version 6 implementation, also MCP networking changes we've made to support improvements to AIS connectivity services, secure connections for our dynamic DNS feature, and documentation that we're publishing for best practices for integrating an MCP system to a network protected by Unisys Stealth. The first thing we'll talk about is the transaction processing scalability improvements. Our MCP performance team has transaction processing information from our largest MCP customers, and they are constantly testing it against our latest releases to ensure that we have sufficient headroom as our customer performance needs grow. While testing to find out what the limits of transaction processing scalability were for various application architectures, the team discovered that when rates were pushed to really high levels, that transaction performancing didn't just level out, that the performance became very uneven. This bottleneck was traced to the way that we time TCP segments for possible retransmission, acknowledgements, keep alive, and other activities. The implementation was about 20 years old, and we found that there were scalability issues when pushed to the maximum level of performance. We've spent quite some time reworking that code and testing it extensively with various application architectures. And what you'll find when you use this is at lower transaction rates, which is probably the transaction rates that everyone is using today, there's no noticeable change. But as transaction rates increase, that performance will scale more smoothly now. Next, I'm going to talk about our implementation of RFC 5961. Data transmission rates have increased tremendously since the existing set of TCP standards was put in place. And as transmission rates increase, then larger TCP windows are used to efficiently handle the greater amount of data that's in flight between endpoints. The increased window size has made it easier for an attacker to guess sequence numbers that are in use for connections and to try to insert spoofed packets. The industry came up with RFC 5961 as a way to defend against this vulnerability. And in the last year, commercial vulnerability scanners have started checking for RFC 5961 compliance and flagging non-compliant implementations as a possible vulnerability. Starting with the MCP 19 release, MCP networking has implemented RFC 5961, and it's there by default. It's not something you have to turn on, and scanners will not report the MCP system as vulnerable. As an overview of what the RFC requires, it specifies a TCP IP challenge ACK feature that detects the forged packets and discards them. So frames within the active send window are processed. Frames received that are outside the sequence range are silently discarded. And we've added the command specified by the RFC to allow an administrator to query the number of discarded frames that are not passed on to the MCP TCP/IP stack. Enabling the filtering not only defends you from data injection attacks, but they also protect you against what could basically be a denial of service attack. The way the attack works is that the attacker crafts TCP packets with forged IP source and destination addresses and forged source and destination ports. Without this RFC, the targeted endpoint, which would be the MCP system, might associate a forged packet, might come in and replace the existing packet that was supposed to come in if they guessed a sequence number that was in range and hadn't been used yet. We've added TCP/IP challenge ACK timeout and challenge ACK limit options to allow administrator to manage the defense. And I'll talk about those on the next slide. And those, all of this limits the attack surface. The challenge ACK timeout command sets the time interval defining the duration of a challenge ACK event. The interval starts when the MCP responds with the first challenge ACK, and the interval ends either when the interval time elapses or the connection is closed or reset. Reporting of the event will occur at the end of the interval, and the default interval timeout is 180 seconds. The challenge ACK limit command option sets the maximum number of challenge ACKs that will send during the interval. The value is reset for each interval. A value of the challenge ACK limit of 0, or a value greater than 0 rather, tells TCP to use stricter validity checks for reset and sync segments. And the default value of this challenge ACK limit option is 100. Here are some examples of setting the challenge ACK limit option and the challenge ACK timeout option. For more detail, see the MCP 19 version of the TCP/IP implementation and operations guide. Moving on to TCP IPv6, IPv6 interoperability. Since the MCP support for IPv6 was implemented, the RFCs have evolved quite a bit. RFC 6434 summarizes the new requirements for IPv6 nodes. In MCP 19, we brought the MCP networking implementation of IPv6 in compliance with all of the must requirement for this RFC. There are also some optional requirements. The must requirements included extension header type 0 support. MCP was already compliant with this one. It requires support for IPv6 flow labels. We have added a flow label option to the NW TCP/IP options command. It defaults to false, and you can set it to true with the syntax shown here. And you can see the TCP/IP implementation and operations guide for more details on the flow labels option. The other thing required was host to router load sharing, and that has been added in the MCP 19 release. Next, we'll talk about changes we made to MCP networking to support enhancements to connectivity services. Connectivity services have continued to evolve. and several changes were made. The maximum size of a connectivity services message has been increased to 1 megabyte, and that matches the maximum size that the MCP will accept for TCP/IP message. This refers to the size message that an application can pass to connectivity services. If you're streaming large amounts of data through maximum size messages, then this will improve performance and basically makes it so that connectivity services can hit the same data transfer rate that a TCP/IP connection can. Also, as part of Outward Web Services, we have enhanced the MCP implementation to support client-side connectivity services applications. We've also enhanced connectivity services, authentication services to allow the client applications to provide access credentials using NTLM-v2 when connecting to a server. And we have added the ability for a CS client application to specify a default credentials file to provide server credentials, making it easier to implement CS client applications. Moving on, the next thing we'll talk about is authentication for dynamic DNS updates. In MCP 18, we gave MCP networking the ability to obtain IPv4 addresses through a DHCP server. And we added the ability to post the new IP address with the server name to a name server. The MCP 18 dialog with a name server is in clear text, which was the original implementation for the dynamic DNS protocol. Most of our customers want to be able to use secured connections with their name servers. So on MCP 19, we have implemented Kerberos authentication to the DNS. And information for how to do this can be found in the TCP/IP implementation and operations guide. The last thing I'm going to talk about today is best practices for connecting an MCP system to a network secured with the Unisys Stealth product. MCP systems already have been able to participate as an endpoint in a Unisys Stealth network. The MCP system is connected to the network using a Stealth virtual gateway appliance. There's no new code for the MCP implementation or for Stealth or for the Stealth virtual gateway here. This is purely a documentation deliverable. When MCP 19 release ships, we will add a document to the support website describing the best practices for connecting the MCP system to Stealth using an SVG. As I'm concluding here, I've been asked to remind you that Unisys offers a comprehensive set of ClearPath forward services that can be used for working with the features I've described today and many other things. Please contact your Unisys representative for more information. Thank you for your time today. I hope you found this informative.